Now, while we've talked about how we can use draw poly, let's take a moment to see how we might be able to use vector-based graphics to draw a grid. So as we begin to draw our grid, of course, the first thing we know we need to do is what we've been doing all along, or simply including our turtle. In this case, we're going to go ahead and set our title to the name of the file so that we can display what you should be looking for if you have to reuse our code. And the next thing we need to do, of course, is to simply include our draw poly capability. Nothing new here, pretty much as we have discussed previously. What we might expect, however, is that in this case we're going to have 4 sides to our polygon. That's easy enough to understand. And although we do specify the length equal to 50, we go ahead and specify it here again, and we will provide it to draw poly simply to allow us to change our logic in case we want a bigger grid full of larger squares. Now we understand that a grid has so many lines high and so many cells wide, and in this case we're simply going to have our high to be part of the range of our sides, and we're going to have to go across or wide, and we understand that we're going to have to draw poly. And if we go ahead and run our program now, you can see that not much is really going on there. We're just going over and over and over again, as you may expect, and that's certainly not what we wanted to see. So obviously what we need to do, of course, is to advance. Once we draw our poly, and of course you want to move forward for the length that we specified, as well as provided to draw poly. Running our module again, you see now we are properly moving over for the number of cells we want, but we keep on moving over and over and over again, a lot farther than we probably wanted to move. So obviously the next thing we have to do is find a way, when we're done drawing what is wide, to move up to the next row. Providing the sides a length once again, the only thing we have to do now is to create our next row function. And as you can imagine, it's not that different from what we've talked about beforehand. But since we're going to wake up in the upper right-hand corner, we're going to have to move relative to our turtle left 180 degrees, or an entire line, and then move forward for the length of the entire side that we're drawing, effectively going backwards 180 degrees, then begin another motion to move right up, then forward the length, and then begin our movement once again. So taken together, our next row capability will allow us to reverse, go right, move up the length, as well as go right again, and put us into a position where draw poly will continue to draw our grid as we expect. Running our module, therefore, we see now, as we talked about, we're going to draw our squares, and our squares are going to stack nicely on top of each other, and we will find that we have now created a nice 4 by 4 grid using our draw poly capability. So we see, using draw poly, it can be pretty easy to draw a grid. But did you see what was going on? Could there be a better way? Well, let's first take a moment to recreate what we have just demonstrated for ourselves. Reusing your own draw poly and moving both across the width as well as height of your screen, see if you can challenge yourself and create a nice square of squares so as to create a grid, because as we all can imagine, being able to measure our work and use a grid to exactly track what we're doing is a very useful capability to have and should be part of our standard toolkit. So go ahead, take a moment and create your own draw grid function. And we'll be here to show you our solution and perhaps a better way of doing things in the next presentation.